Okay, so we are starting a new unit, Unit 5, and it's all about systems of equations. So before we get into that, we need to think, what is a system of equation? So last unit we learned about linear equations. This unit, all the systems of equation it is actually I don't want to use system, it is two or more linear equations. So last unit we talked about one, this unit we're talking about two. And you solve a system of equation, you solve these systems of equations two ways. One, you solve it graphically, and then two, you solve it algebraically. So graphically, when you solve a system of equation, what does that mean? It means where do those two lines intersect? And two lines that intersect on a graph, so that gives you a coordinate point is going to be your answer. Algebraically, what is the solution to a system? It is the point that makes both equations true. We're going to talk about that when we get to that section. There are three different types of solutions. So we're going to be looking at a graph, and there's three different things that your lines can do. One, they can intersect, right? They intersect. And so then you would have one solution, and when you have that one solution, you would name that point. So you would name that point, X and Y. If lines are parallel, now, what do you know about parallel lines from last unit is parallel lines have the same slope. Same slope, and they never intersect. So if they never intersect, they're never going to have a solution. They're never going to share a common point. So no solution. And then when you have the same line, they overlap each other, and that means you're going to have an infinite number of solutions, right? It's at every single point they share, so an infinite number of solutions. All right, when you solve systems graphically, what are our steps? Well, step one, you put it into slope-intercept form. Step two is you graph it. And then step three is you name that point. It's that simple. So if we look at number one, it is already in slope-intercept form. So all I'm going to do is I am going to name in red, my beginning point is -8, the constant term, remember that's your constant term, and your slope is +1 because that's your coefficient in front of x. And you guys know that from last unit. So now I'm going to graph this line in red. My beginning point's -8, right here, and my slope is +1. So up 1 over 1, up 1 over 1. Remember, I'm going to go through the graph as many times as I can, and I'm going to graph that line all the way through, arrows on both ends. I'm going to graph this other line in blue. And so my beginning point of that one is 1, and my slope is -2. So I start here, and I have a slope, a slope of -2, so I get down 1 over 1, down 2 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 over 1. I repeat it till I go all the way through, arrows on both ends, and I can clearly see this intersection point. So I'm going to name it. If I named it, my x value is +3, and my y value is 1, 2, 3, 4, -5. That means they share this common point. That means if I plug in 3 for x, so 3 minus 8 gives me -5 for y, and that's true. And I can do it in this one. If I plug in 3 for x here, -2 times 3 is -6, and -6 plus 1 is -5, and my y value is -5. So that makes both of those equations true. All right, let's take a look at number 3, or let's jump to the next page. All right. Okay, so now when we look at number 3, these are not in slope-intercept form. So the first thing I'm going to do is move it into slope-intercept form. So I'm going to get y by itself. So I'm going to add 3x to both sides. And I get y equals 3x plus 8. Since I'm in blue, I'm going to go ahead and name my beginning point as 8. Remember, your beginning point's your y-intercept. and my slope is positive 3. So I'm going to go ahead and graph it. My beginning point is 8. My slope is positive 3, up 3 over 1. It goes off the grid, but that shows me the direction of the line. So now I can reverse it. Down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. And I'm going to go all the way through my grid, arrows on both ends. All right, now in red, I'm going to get y by itself. So I'm going to add x to both sides. And I get y equals x minus 2. So my beginning point, my constant term is negative 2. My slope is positive 1, that coefficient in front of x. So my beginning point is negative 2. My slope is up 1 over 1. And I reverse it so I can see where they intersect. They intersect right here. And they intersect at 1, 2, 3, 4, negative 5. And 1, 2, 3, 4, 5, 6, negative 7 on my y. So one solution, and I'm naming that point. All right, let's take a look at number 5. So my first step is to get it in y equals mx plus b form. So I'm going to move it down here and get y by itself. So subtract x. 3y equals negative x minus 15. Divide everything by 3. And I get y equals negative 1/3 x minus 5. Oops, x is on the wrong side. And that's a negative. Negative 1/3 x minus 5. So my beginning point's negative 5. My slope is negative 1/3. So I begin on my y-axis. And I go down 1 over 3, down 1 over 3, down 1 over 3. And reverse it all the way through the graph. Arrows on both ends. And now, remember how we graph this line. Right? My beginning point's negative 7. 1, 2, 3, 4, 5, 6, negative 7. This is a good situation. My skier's alive, so he's going to zoom straight across. And this is where they intersect. So I'm going to name that point. And it's 1, 2, 3, 4, 5, 6. Positive 6. And I go down 1, 2, 3, 4, 5, 6. Negative 7 on my y. So that coordinate point is 6, negative 7. And I can check my answer by plugging 6 and 7 both in for x and y, and then checking to make sure that equation is true. Okay, let's look at number 6. I want to do number 6. Okay, this is already in y equals mx plus b form, so I'm going to graph it. My slope is 1. My beginning point was 5, and my slope was 1, so I'm going to graph that all the way through. And then I'm going to change this guy to red and get y by itself. So negative y equals negative x plus 2. My y is negative, so now I'm going to do the opposite of everything. And I get my beginning point's negative 2, and my slope is 1. Now, look at this. We set up here that our slope is 1, and my slope is 1 here. So right away, slopes, parallel lines have the same slope. So if my slope is the same, I'm going to graph parallel lines. So it's a way to check my answer. So now I'm going to graph negative 2. My slope is positive 1. So how many times do these lines intersect? Never. So there is no solution because they never intersect. All right, let's do one more. Let's do this guy. All right, let's do number 8. So remember to graph this line. That's a bad situation, x equals. So x equals negative 2 is an undefined slope. So it looks like that. And then in blue, I'm going to get y by itself. So I subtract 3x to both sides. And then I divide everything by a negative 2. Be careful of your signs. I get a positive y, a positive 3 over 2x, and a positive 9. So my beginning point's 9. And my slope is 3 over 2. And remember, we begin graphing on your y-intercept. So 3, 6, 7, 8, 9. My slope is positive 3, so I would go up 3 over 2. It goes off the grid, but now I see the pattern of positive 3 over 2. I can reverse it. And I already see where they intersect. But I'm going to draw my line. And this is where they intersect. So at what point do they intersect? They intersect where x is negative 2 and y is 1, 2, 3, 4, 5, 6. Okay, so that's graphing linear equations. If you're struggling with anything on this video, please come see me sooner rather than later.